Hello everyone, welcome to this tutorial. Today we will discuss on LeetCode problem number 2353, which is design a food rating system. Okay, so let's go to the problem description first. So we need to do two operations. First, we need to design a food rating system that can do two operations. First one is modify the rating of food item. And the second thing is return the highest rated food item for a type of cuisine in the system. Okay, so let's suppose we have multiple cuisine like Indian, Japanese, Korean, Chinese, all like this, right? And each cuisines will have some corresponding food items. So in Indian cuisine we can have something like pav bhaji, pani puri, and so on, right? Now that each food will have certain ratings, right? So let's suppose I am giving pav bhaji 7, pani puri 8, like that, right? So that sort of ratings will be there for each food. And we need to return we have one function and we need to return the highest rated food item for a type of cuisine. So let's suppose someone asks me tell me the highest rated food for Indian cuisine. So I will return pani puri here because I have pani puri is highest rated for in Indian cuisine, right? So that's how we need to implement a food rating system. Now, here in the so we have this structure that we have this food rating class, right? Like this. There is this constructor, right, which contains vector of a strings uh, of foods, then cuisines, and then the corresponding ratings, which means that this ith food item will have this ith is of ith cuisine and is of ith rating, right? So, for example, I have pani puri at index 0, then index 0 in the cuisine will be Indian, and index 0 in the rating, let's suppose, is 8. So, what I can say, okay, so this pani puri food is of Indian cuisine and it has a rating as 8. Now, we have this another function, which is this void change rating. It has two parameter. One is food and one is new rating. So, of course, by the name we can assume that what it will do, it will change the rating of the corresponding food with this new rating, right? And there is this third function, which is highest rated, and it has the input parameter as cuisine, and this highest rated function will returns the name of food item that has the highest rating for the given type of cuisine. So let's suppose here I have an input as Indian, right? So I should have the list of all the food items which belongs to the Indian cuisine. Then I will return the highest rated food item from that list, right? And if there is a tie in between the rating, then we will return the lexicographically smaller food, right? Now, let's understand this with this example as well. So, here we have this list of food, then the corresponding list of cuisine, okay, and the corresponding list of rating, right? This is being called in the construct. So we call the constructor here with these values, right? The food list, the cuisine list, and the rating list, right? So initially, the kimchi is of Korean cuisine and it has a rating as 9. Similarly, miso is of Japanese cuisine and it has a rating of 12, like this. Okay. Now, there are certain inputs, right? So first one is this highest rated, and it has the input as Korean. So I need to return for Korean cuisine the highest rated food item, right? So we can see here that for Korean there are two food items. One is this kimchi and another one is this, right? And out of these two, if you see the first one, which is kimchi, has a rating of 9, and this food item has a rating of 7, right? So for Korean cuisine, the highest rated food item is this 9, which is kimchi. So we return here kimchi. Again, we have asked return the highest rated food item of Japanese cuisine, right? So we see here that there are three Japanese food, right? One is miso, another one is sushi, and the last one is ramen, right? For miso, the rating is 12. For sushi, the rating is 15. Sorry, for sushi, the rating is 8. And for ramen, the rating is 14. So out of these three, the ramen is highest rated, right? So we return the ramen here. Now in the third call, we have been asked to change the rating. So now the sushi rating is changed to 16. Initially it was 8, right? Now we change it to 16, correct? Again we ask return the highest rated Japanese cuisine. Now remember, for miso it is still 12, but for sushi it is now 16, and for ramen it is 14 only. So now the highest rated food is sushi. So we return here sushi. Again, we have been asked to change the rating for ramen to 16. So again, we change the ramen rating to 16. And again, then we have been asked to return the highest rated food item for Japanese. Now again, see, for miso, we still have 12. For sushi, we updated it to 16. And ramen is also updated to 16. Now there is a conflict. We have two food items with same rating, which is 16. So we compare the food, so we will return the food which is lexicographically smaller. Now, these are the two strings, right? One is ramen, another one is sushi. So we start comparing the character by character from the first index. So we compare this R with S. R is smaller than S, right? So we can say that ramen is smaller than sushi. Hence, we written ramen here. That's how that's how we compare the two strings lexicographically, right? I will not go deep in it, but yeah. So we return since there is a conflict on the rating, so we will return the lexicographically smaller string, which is ramen here. I hope you get this explanation, like how this is working, right? Now, see, such kind of problems are designed to help you understand which data structures you should choose, right, to solve these problems. So, the prerequisite to solve such kind of problems is having a good knowledge on data structures with their time complexity. The first thing is that only. Okay, if you know what are the data structures I can leverage here and which will be the best suited for this in terms of time complexity as well, then you can easily solve such kind of problems. The implementation is not that hard. You just need to understand the data structures, right? We need so in order to understand what data structure can uh, can I pick in this design which will comply this constraint, right? You should know the time complexity. Okay, so first we will go to the constraints. So here n is number nothing but the number of foods, right? So it can be maximum of 2 into 10 raised to power 4, right? Cuisines and food of I and cuisines of I always consist of lowercase English letters, which is okay. Food are always distinct, so the foods string is always have the distinct value. Okay. Um, Food will be name of a food item in the system across all the call to change rating. Okay. Cuisine will be type of cuisine of at least one food item in the system across all calls to highest rated, right? So what does it basically means here that when we get this input parameter food, that means that food already exists in our design, like during this initial call, right? And if we get input parameter as cuisine, that means that cuisine should have at least one food, right, to return that value. Okay. And at most there are 2 into 10 raised to power 4 calls in total will be made to change rating and highest rated. So these two functions combinedly can have at most 2 into 10 raised to power 4 calls. Okay. So n, which is nothing but the length of the number of food we have is 10 raised to power 2 into 10 raised to power 4, and the maximum time our this food writing app will be called as 2 into 10 raised to power 4. Okay. Now let's understand what we need to return here, and based on that only we will understand what kind of data structures we can use here, right? Now, first thing that you observed here is for each food, I should know the corresponding rating, and for each food, I should know which cuisine it belongs to, right? Okay, so with that information, we decided to create hash map which has a key value as food and key as food and the value as rating, right? One hash map is this, and another also we will define, which will contain the corresponding cuisine information for each food. I hope you get it till now. Okay, so that we know that okay, this food has this rating, and this food is belong to this cuisine. So that what we will do here, right? So we will just iterate to all the and food items we have here. We will store the rating of each food, right? And then we will store the cuisine information as well of each food. Like this food is belong to which cuisine. Okay, one part is done. Now this function, right? What it wants and what we should perform here. So this says that the food rating is changed, right? So we can simply update this particular map function which we have written where we are storing the rating of each food, right? So we can just simply update this that food rating of food size is equals to new rating, right? Now let's come to this function. Now what it wants. it wants the highest rated food for that particular cuisine. Now, do I have the information that okay, for this particular cuisine, these are the food items I have? No. Food to cuisine information I have that okay, this food is belong to this cuisine. But did I have that information that okay, this cuisine will have these number of food items? No. So for that also we need to create another data structure which will hold this information, right? Now, when we will store this food items, right? Let's suppose I am creating a one certain I store this list of food items for that particular cuisine. But then that food item should always be in some kind of ordered way, right? It should be stored in descending order so that I can just return the starting food item, or if it is in ascending order of the rating, then I can return the last food item exist in this cuisine. What I'm trying to say is, first for each cuisine, I need to maintain list of food items in ordered way. Why ordered way? To return the starting food item or last food item based on the way it's it is stored. Ordered way by rating, right? Either I will maintain the food with us their ascending order of ratings, or either I will maintain the food with their descending order of ratings. So based on that, I can either return the starting food item or the last food item, right? To get the highest rated food item. Okay. Now can you think which how can we solve these two problems by creating a like by having this one data structure only? I am pretty much sure that you get this idea that okay, for each cuisine I need to maintain certain information. Then I can have a data structure, kind of a hash map, where the key will be cuisine. So I will go to that particular hash map, right, where the key is cuisine, and it will contain some set of food items. Now remember, I said set here because set will store your food items in ordered in ascending order based on the set can help to store your food items based on the ascending order. Hoping you're getting this right. Now there is one challenge. Okay, so when we will create that particular, so let's create it. Okay, we are sure that we need a one map or hash map which will have the key value as cuisine, and then it will contain some set of food items in ordered way by rating, right? So it will have basically two pair of information, right? One is the rating and another one is the corresponding food value, right? Food information. So a string. This we can call as cuisine food map something, right? Cuisine food because it has cuisine to food information or cuisine food rating. Okay, hoping you get this. Now there is one more thing, right? So we create a set function which will have the pair of values. First it will restore the rating, then it will restore the string, right? Now if we go with having this in ordered value, like if I just keep inserting rating and the corresponding food value, then it will be stored in ascending order by default because that follows to store in ascending order only. Like, right, whenever we insert in set, it by default store the information in ascending order. Right, now I'm saying that okay, the food item are stored in such a way that the first value will have the lowest rating, right? And the last value will have the highest rating. But consider a scenario where the last two values of your this particular set has same rating, right? Let's suppose last two value is like this 10 comma food 1 and then 10 comma food 2. Now you need to know that okay, if how set will store first this these two values, right? Since the ratings are same, so it will compare the second value, which is food string, right? And it will store the food string as well in the ascending order. Okay, so this tan and food one will come first because food one is smaller than food two. Food one is lexicographically smaller than food two, right? So at the second position we will have the last second position we will have 10 comma food 1 and then at the end we will have 10 comma food 2, right? Now we are saying that okay, our the food are stored in such a way that the first value will have the lowest rating and the last food item has the highest rating. This is fine. Highest rating here is 10 and your last food item also has the highest rating. But there is a possibility that last second food item also has the same highest rating. In that case, we have been asked to return the lexicographically smaller food item, right? So in that case, we need to return this value, right? Rather than the last value, correct? But then, in the worst case, what will happen when all the food have the same ratings? Then we will keep iterating this set list, right? And we will keep iterating. We will keep iterating until and unless we don't, this highest rating is same. And let's suppose we got to the first value only because all has the same rating. Then does it not increase our time complexity? It will, right? Again, I'm explaining this that in the worst case, if the rating of all the food items are same here, then we will keep it rating from last to right positions. that okay, this has the same rating, so I will go this last second value. Now I found that the last third value also has the same rating, so I should return that value because the food string is lexicographically smaller. But then I found okay, last fourth value is also has the same rating, so I am just keep iterating that until I found that okay, the first value of the set also has the same rating, and then I return the first value. So I just iterate here all the values like n times, right, in this set, which will increase my time complexity. So how can I handle this? Now this will solve our problem. If we will store, if we have the food 1, food 2 like this, right? The strings are stored like this, but the ratings are stored in opposite way. What I mean to say here is that okay, this tan is food 1, tan is food 2, right? So rather than storing the set as a regular in a regular way, like in regular ascending order, we can store that in some twisted way. Now, what twist we can bring here? Rather than storing the rating, we will store the minus of rating. Now, what benefit you will get with this? Understand? When we will store the minus of the rating, that means the highest rating value will now come at the first position. Why? Because the negative of the highest is smallest. Okay. So the food item will be stored in such a way that the highest rating food item will be at the first position. And if the ratings are same, then it will contain the lexicographically smaller string at the first position. So in both the way, right? Even in terms of rating or even in terms of returning the lexicographically smaller food, we are good to say that we will always return the first value of the set, right? So now we decide that we will store this cuisine in such a way that we will do the negative of the rating and then we will store here so that the highest rating food item actually it is rating at 10th, but since we have applied the negative value here, so now it becomes smallest in terms of max, right? And hence it comes to first position. Okay. So what we will do, we will store the cuisine food rating as well here, right? So cuisine food rating of cuisine I, we will insert this set of pair. So first we will store the rating and rating will be minus of ratings I, and then we will store the food I. Got it? So I hope you get it that this last two value will be like this. Now when we will store it when we will store the ratings in negative form, our first two value will become like this. And we can simply return the first value here. Because in both the ways, in terms of ratings or in terms of being lexicographically smaller, this will always be at the first position. Okay. So can we say that okay, it's very easy now for this function to implement? What I need to do? I will first go to this hash map. I will go to the set. I will go to the cuisine wala set, this cuisine set, and then I will return the first position of this set. So this begin function will give me the first position element, but since it is a set, it will give me the iterator. Now to get the value from the iterator, we just need to add the star here, and also we only need to return the food, right? Food value. We don't need to return the rating. So now this will give us the pair, right? Which has the rating and the food as well, food value. So I will just return the second element, which is food. Okay. So this is the only thing that I want to return. Now talking about the time complexity, it for this function, right? Let's just go to the time complexity as well, as in when we are implementing this function, so that we get to know, okay, this will comply these constraints or not. Now, what is the maximum time this function can be called, right, is m, right? We have been told that okay, at max 2 into 10 raised to power 4 calls can be made. So the maximum call is m, which is 2 into 10 raised to power 4, right? Now we are returning the first value itself, right? So it will be just O of m. We don't need to return, we are not doing any sort of iteration or something. So the time complexity here maximum can be O of n, which will suffice this constraint, right? It can easily accommodate this. Now let's go to this function as well, this constructor, when we are doing this initialization. So here the time complexity will be, let me return here that m is number of times this function is called. Okay, so now here, first we are iterating to all the food items. Now there can be maximum n food items, right? So, first is simply O of n. Now within this, when we are for each food item, we are doing the insert in set, right? So the set can have the maximum of n values, and we know the insertion of set will take log of n. So it will be O of n log n. Hoping you get this as well, right? Now let's go here. Now the what we need to do when the food rating is changed. Can we just simply assign the new rating here and just return? No. Here also we are storing the rating, right? So here also we need to do some sort of changes, right? Here also we need to update with new rating. So first what we will do, since here we need to make changes, that means here we need to know which cuisine it belongs to. So first we will extract the cuisine information, that which cuisine this food will belongs to. So how can we get this? We can get this with this particular unordered map. Okay, this will return us which cuisine this food will belongs to. Also, it is a great idea to get the old rating of this food. So what will be the old rating? The existing rating which is stored here for this food. Okay, I got the cuisine information, I got the old rating as well. So first thing is I just initialize this food rating with the new rating, and also I need to make the changes here. Here also I am storing the rating information, right? So what I will do, I will first find, I will first go to that cuisine, right? Setting the set pair where I will have this food. I need to get that uh, pointer object of that iterator in the set, right? Where this food is stored. So auto iterator, which will return as the iterator value within the set where this food value is stored. So what we will do, we will go to that cuisine and we will apply the find function. And what we need to find here, since set is a pair of rating comma string, so this food must be stored with old rating and this food value. Now remember, the way we are storing rating is we are first doing the minus, right? But then old rating. Here we are storing just like rating value, right? We are not doing any sort of minus here. So what we will need to do, minus old rating comma this food. It will give us the pointer object where this existing value is stored with this food and this rating combination. Now what we need to do again? Now what we need to do? We need to delete this value from the set, right? So how can we do that? We will just call this set function again. We will call the erase function and we will just give the iterator so that it will delete that iterator. Okay, then we deleted the existing food value from the set. Now again we need to insert it with this new rating, right? So similarly the way that we have stored here, similarly what we will do is using food rating dot insert. Now again the rating will be stored in negative way, so we need to do minus of new rating comma food. Now are we good? Yes, we have updated the ratings wherever we stored. One is this map and another one is this hash map, so we are good here. Now let's understand, are we good with the time complexity as well here for this function? So again, the maximum number of time this function can be called as Now for each iteration, what we are doing? We are just updating the new rating in this. It will take constant time because this is just a hash map and we are just simply updating the value of the corresponding key. So it will take O of one time only. The find operation in the set will take log of n, right? Maximum food item the set can have is n only. So the find operation will take log of n. Again, delete operation will take log of n. And again, the insert operation will take log of n. So for each iteration, which is for each call, there is call, and for each call we can have a maximum time complexity of O of log n. So it will be O of log n, the maximum time complexity for this function, right? So in total, we will have the time complexity of O of plus n log n. So here the total time complexity will be O of, either we can write like this, log n plus O of log n, which is equivalent to O of plus n log n. I hope you get the solution. It's a bit complex because we have used a data structure like within the hash map we have used that, and of course we need to do a certain operations here. But please do go through the video again if you don't understand it in a one go. And please try to solve this by yourself and also try to understand how the time complexities are calculated here. Okay, yeah. If you yes like this video, please do like and share and subscribe. Yeah, thank you. Bye. Oh, I'm sorry. Yeah, I just forgot to submit this, although our test cases let me also run this code, right? I just do the explanation. No, I think, oh, okay. This is not writing, it is a teacher, right? Do we have anything here? It's like set of theory. Are we missing something? This one belongs to this. Okay, there is another more I need to add. A lot of mistakes I'm making. Okay, semicolon is missing here. Let's try to run the test case again. It's not foods, it's food. Anything else I've written foods here? No. Okay, now it is accepted. I'm sorry with this. But remember when you were in placements now, these kind of mistakes is also not good for you. So remember to go through that code once again and just identify if you have any such kind of mistakes, right? So yeah, now let's try to submit this. Okay, our code is submitted, right? So yeah, that is how we are going to approach this and solve this problem. There can be multiple ways, like instead of using the set here, I can also use the priority queue because priority queue can also return like in O of one time only I can get the maximum or minimum value from priority queue, right? So that data structure is also something that I can leverage here. It's up to you guys how you want to solve it. I explain in this video with the set. You can try the similar approach with priority queue as well. Okay, yeah. Again, hope you like this video. Please do like, share, and subscribe if yes. Yeah. Thank you. Bye. Have a nice day.